just going to do a bit of recap on composite functions because we're going to use that in a moment when we're looking at differentiating functions which look like a combination of two functions. I'll explain that in the next clip, but let's just do a recap of composite functions. If I had, let's do two examples. If I had a function f of x equals something like x cubed plus 3x, and then a different function g of x equals the root of x. Okay, then what would this be? What would gof be? Okay, g of f of x. Okay, so remember how that works. Okay, we are concentrating on f, okay, first, and we're sticking f inside the function g. So wherever you see, let me do this in sort of like purplish colour, wherever you see, so we're going to take this and we're going to put that wherever we see an x in this function. So we just have one x, so we're going to stick it inside that bit there. So the function is, well, a big square root, and then we'll have x cubed plus, okay, that's supposed to mean x cubed plus 3x. Okay, and that's g of f of x, right? But what we're going to look at in terms of differentiation, where we're going to use this, is sort of trying to work backwards from this. So let's say I gave you a function like this, okay? Let's say g of f of x was equal to this, 1 over big square root x plus 3x squared. Okay, so here's a composite function here like this, okay, 1 over square root of x plus 3x squared. But I've just told you it's a composite function, but what if they just said, you know what, this is just some function h of x, alright? Now, well, let me just put that back. Well, can you then go backwards from this and determine what the two functions f and g respectively could have been, okay? And there's actually two different ways of writing this, okay? Well, for example, well, what could f and g be, alright? Well, let me put f of x, g of x. Well, one particular example, f could be just this little bit inside here, right? fx could be x plus 3x squared. Okay? Then what would g of x have to be? Well, g of x would have to be, the rest of it would have to be 1 over, well, the root of x. Okay, so if I imagine you just put your thumb over this bit and replace that with a giant letter x, well, there you go, and that's what that would be. And that would work, because if I put this inside that x there, I get my function over here in orange, right? That's just one example. Let me rub out these yellow bracket bits. Okay. Now, that's one example. There's also another potential example. It could also be this, you know, f could also be equal to the square root x plus 3x squared. Basically the whole denominator here, right? Then g of x would have to be equal 1 over x, right? Because I could take this and then replace the x with that, and then I still get the same thing. So we've got two different things, two combinations of f and g that give us the same result. And what we're going to look at later on is we're going to look at how we differentiate functions like this. Okay, how we differentiate functions like this. And the trick to it is to split it up into two separate functions, f and g like this, and differentiate each bit. But it's which one you choose, because which combination you choose is the important bit. Because one of these combinations is easy to differentiate with, and one of these isn't. Right? For example, these two here, I can differentiate both of these functions quite easily. These two. Is quite easily, you know, this here, I could rewrite this as x to the power of minus a half, right? And differentiate that. That's easy to do. So if I was asked to differentiate this function here, I'd split it up into these two, because they're easy to do, right? These combinations here are a little bit harder to do. It's not the g, I can differentiate that. It's this root of x plus 3x squared. I don't quite know how to do that. So well, this would require more work to do. You could do it, but it requires more work. So I would definitely use this breakdown of this function to differentiate it, okay, because it's just easier to do. And we're going to look at composite functions, and we're going to look at how to differentiate functions like this, which you haven't quite seen yet. And we're looking at how to go backwards from these. We're going to look at splitting them into composite functions and differentiating it, and then finding the gradient function for a function like this. But this clip is just about taking a function and looking at what potential separate functions could combine to get you this.